Hi guys, and welcome to this, my 2020 Further Maths Paper 1 exam video. Yes, taking slightly longer. Last year I think I got it out on the night. This year I wanted to make sure that I had the time to do this well, because there was some errata last time and I didn't want to rush it. So this is the video. If you are watching on YouTube, do me a favor, can you like the video, subscribe to my YouTube channel. I'm never going to be rich, never going to be famous, but it's really nice just to know people are watching. If you are watching this throughout the year, then good luck with your forthcoming Further Maths exam. If you have just completed it, hopefully you have smashed this. We'll have a look now. Now, I'm not just going to give you the answers, I'm going to give you, for many of the questions, the ways of working it out. Hopefully that's going to be useful. It's going to be a long one. And so hopefully you will see either below or above, depending on screen real estate, that I have captioned which particular part of the video we're dealing with core and which one is dealing with each of the modules. Now, because it's 2020 and COVID, obviously things changed and there were only two main modules, or the two core components, and one module, and I think pretty much most of the country did matrices. So fingers crossed we'll agree. If at any point there are errata, rather than making me redo this video, which is a lot of work, I'll probably put them in the comments below. So obviously, if you're not sure, load that up bit first and off we go. I'm Darren, Maths Guru. Let's make a start. So the data analysis. Data analysis was the first section, and there was like 947 questions, and hopefully you felt they started relatively easy. It wants the difference in milliseconds between the mean time and the median time. So we've got the mean time of 220, the median time of 150. Now, a lot of these I'm not going to do the calculator work for. Fairly sure most people can put 220 minus 150, and I think that gave me C as the correct answer. All right, nice, easy start. Question number 2. Of these 800 times, the number of times longer than 300 milliseconds is closest to. Now again, because we have 300 milliseconds here, we know that that is the limit of our third quartile. So drawing sort of a box plot, we know that there are 25% of data items in each of these quartiles. And we know that this limit now, because they've told me this is 300. So effectively, what the question is now saying is, well, do you realize that we're looking for 1/4 of 800? And again, because there are a total number of 800 sort of data points, I want 1/4 of them. Again, probably you don't need to put that into my calculator. Halve it and halve it again gives me 200. The shape of the distribution of these 800 times is best described as. Now again, I think this is a bit of a trick. If we look at the maximum data item here, that is massively away from our 300 here. What was our lowest value was 10. So I'm fairly sure that's an outlier. So it's probably going to be looking for an idea that there is an outlier. So that gets rid of A, B, and D. And we just need to work out whether it's positively or negatively skewed. And again, I think it's positively skewed. So I got C as the correct answer. So I'm just flicking over my answers to check. Question number 4, the histogram below shows a distribution. Now, when I looked at this question, the most important part here was the number of items, 252. And it wants to know the third quartile for this distribution could be. So because it wants third quartile, it's saying, well, let's split our data up into 4 sections and effectively find out where our sort of third quartile, give me a number for each of those. So what I did firstly was say, well, okay, we've got 252, and I'm going to divide that by 4. So 252 divided by 4, just because I didn't write this down in my notes, gives me 63. So I'm looking for the 63rd data item. Scrolling in or zooming in just a bit, it now meant that I had to add all of these together. I'm trying to find the 63rd data item from that end there. So this was a height of 6, and then I think that was 2, 4, so that was 3. Again, I'm just going to copy these down from my piece of paper. 10, 10, 15, and 23. Now, when we add those together, 6, 9, 29, 39, 39, 40, 41, 42, 43, 46, 56, 66. That means the 63rd data item is going to lie in there somewhere. Now, obviously, the next part of the trick was, did you realize that these were actually half units wide? So that class interval, as we call it, was 0.5. We're looking for a data item that falls somewhere between 30 and 30.5. So let's zoom out again and see what our potential answers were. And again, the only one that I think that could have been was C. All right, so again, a lot of quartiles and sort of statistics-based questions, which obviously it's the data section. A histogram below shows the distribution of weight in grams for a sample of 20 animal species. Right, it's a log scale. When I teach my kids at school, I always say, first things first, remember that 10 to the power of 1 is 10, 10 to the power of 2 is 100, and that these 1, 2, 3 numbers are just powers of 10. So I get my kids to write this out as 10, 100, 1000, 10,000, and then I start saying, well, okay, well, let's look. The percentage, now again, a bit of a trick to this question here, of these animal species with a weight of less than 10,000 grams. Well, that basically is 10 to the power of 4, which means we are looking for the value of log 4. Well, there we go. There's my log 4. It wants to have a weight of less than. So when I add those together, I get 12, 2, and 3, which makes 17. And I'm sure a lot of people would have gone, oh, okay, but it's 17%. No, it isn't, because this was a frequency. It wasn't percentaged. And so we have to do 17 out of the total number of 20, which when you put that into your calculator, basically gave you 85%. He says, hopefully, yep, 85%. A percentage segmented bar chart will be an appropriate graphical tool to display the association between, again, the Cambridge Further Maths textbook's got a table. Hopefully you have that in the summary book, and it beautifully turns around and says that in that situation, you will be looking for categorical data, all right? So categorical data and categorical data, because if you remember, you know, a percentage, what was it? A percentage segmented bar chart basically has something like year, so that would be, sorry, month, which would be January, and then you'd be looking for some sort of categories here to sort of work out what you're going to be, and that would give you D as your only answer, because all the rest of them aren't numerical values. Data relating to the following 5 variables was collected from insects and were caught overnight in a trap. The number of these variables that are discrete and numerical. So numerical, color is not numerical, and nor is name of a species. Okay, number of wings it's discrete because it can only take whole number values. Body weight in millimeters is a measurement, so it's continuous, as is body length. I think I said those the wrong way around, but what I'm basically saying is those are continuous, and in which case A is the answer, or the answer I think it is, because there is only one discrete numerical variable here. All right, the wing length of a species of bird is approximately normally distributed. I tend to get my guys to draw a normal distribution here, put a center of 61, and then split it into 3 sections and write the values on. Now, the reason I do this is because generally speaking, they always try and trick people by using numbers in the question. And if nothing else, it's 10 seconds of my time that I won't never get back, but I will be able to hopefully do the question. Right, using the 68, 95, 99.7 rule for a random sample of 10,000 birds. That's going to be important. The number of these birds with a wing length of less than 57. There we go, less than 57. So the first thing we need to do is we need to work out what percentage of my data is there. And they've told me to use the 68, 95, 99.7%. So what I now know is that this section here and this section here make up 5% of the data. Why? Well, because to 2 standard deviations, there's 95%. We do 100 minus 95 gives me 5, but that's split between the 2 sections. So there is 2.5% of my data. So we now need to work out 2.5% of 10,000, which is 2.5 divided by 100 times 10,000. And once again, when you put that into your calculator, if that's what you want to do, then you get 250 as the correct answer. You can also do it pencil and paper, as I've sort of just done there. Question 9, very much built on the same idea. Now they're just trying to trick you in terms of percentages. They're giving you percentages. So again, we know that normally distributed, so there we go, we've got sections here, split, there's my mean. It's known that 16% of the light globes have a lifetime of less than 655 hours. Now again, if you've got this in your summary book, you will know that 16% of my data basically puts me here. So that now means I can put 655 here. Now the reason I've colored in the sort of left-hand side, he says, pointing hopefully for the camera, is because it wants less than 655. He goes on and says, well, 50% of the light globes have a lifetime that is greater than 670. And again, 50% of my data would be all of this. And actually, that's a bit of a trick, because what they're really telling you there is that you have the mean of 670. Looking at the question then, it says, well, which of these are now true? Well, first things first, we're looking for a value of mean of 670. So that discounts basically A and B. And do we know what the standard deviation is? Well, absolutely. We know that it's the distance between the mean and one of our standard deviations there, or our first standard deviation, which they very kindly give me. So 55, 65, 15. So there we go. D, as far as I'm concerned, was the correct answer for that question. Right, they're now going to give me a table, and it's looking at the idea of snores and frequency of nightmares, and basically, can you read this two-way table? The variables in this study: frequency of nightmares, low and high, and snores, no, yes. And I know there's been a huge amount of discussion about this online. Are ordinal and nominal respectively, nominal and ordinal, exactly right. So the thing about low and high is it does have an order. So the first thing I know is that that is in fact ordinal. Snores, no, yes. I hate to tell you this, guys. It doesn't have an order. You can't find an implied order between no and yes. Nobody knows whether no is more important than yes. It depends on the context. It's not particularly obvious. And so once again, I'm afraid I have to tell you that that is nominal. And so for question 10, I believe A is in fact the correct answer. The percentage of participants in the study who did not snore. Now again, this is using the table. It wants percentage of participants. That's telling you that it wants a fraction out of 161, because we're dealing with all of the participants, and that's the total there. But it's also saying who did not snore. The total number of people who did not snore is actually 91. And then once again, put that into my calculator, multiply it by 100, and out comes 56.5%. And it goes on to say, the next part of the question is, of those people who did snore, okay, so we're now looking for the total number of snorers, which is 70. So 70 is my bottom number. The percentage who have a high frequency of nightmares, so a high frequency of nightmares was 12. And once again, 12 divided by 70 times by 100 on my calculator came out to be 17.1. Yay! Question 13. A least squares line of the form a plus bx is fitted to a scatter plot. Which of the following is always true? As many of the data points in the scatter plot as possible lie on the line. That's actually rubbish. You know, to be fair, that's not the condition of doing a least squares line. And the trick there is the words least squares. So no, that's not true. The data points in the scatter plot will be divided so there are as many data points above the line as below the line. That's actually the definition of a line of best fit. And that certainly was true when I was at school. We were told that when you try and draw a line of best fit, which is different from a least squares line, it's basically you try and put it so that it's roughly speaking got enough points above and below. It's not actually true in all cases. The sum of the squares, now basically bearing in mind the language of this is pretty much the same with C, D and E. What are we looking at here? It's got to be one of these. And I remember one of my students basically went, Mr. Smith, we were so, I remember I had it in my summary book and I remember that lesson and you were talking about the vertical distances between the points making it the least bit. And that's exactly it. So hopefully your teacher also taught you the idea that least squares lines are given by the sum of the squares of the vertical distances from the line to each data point will be a minimum. And your calculator does some funky mess to make that happen. All right, question 14. In a study, the association between number of tasks complete on a task and the time allowed in hours was found to be non-linear. Awesome. So looking here, we have a least squares line. And it says the equation predicts the number of tasks completed when the time allowed is 3 hours. Awesome. So I now know I have log 10 of some value, let's call it m, is 1.160 plus 0.03617 times by the time they gave me, which was 3. All right, so I did 1.160 plus 0.03617, and I'm going to multiply that by 3, and that gives me 1.26851. Now, that means that the log base 10 of some number is 1.26, what does that say, 851. To get the actual number, I need to raise everything to the power of 10, so that gives me 10 to the power of 1.26851. So I do 10 to the power of, and let's bring up my answer, gives me 18.55, which means C is my correct answer because he wants it the one that it is nearest to. Whoop, whoop. Okay. Obviously now we have sort of changes. We're going to start dealing with seasonal indices. And again, these are just formulas as far as I'm concerned. This particular information or that particular stuff there for the Cambridge books is right at the very end of one of the chapters, but I've seen it so many times. Hopefully my group did really well on this one. So correct for the rainfall in March for seasonality. the actual rainfall should be. Now again, this is a formula. You do 1 divided by the seasonal index. So you would do 1 divided by 0.741. Bring out the calculator. 1 divided by 0.741 gives me 1.34952. Now that's a decimal multiplier, which I can multiply by 100 to give me a percentage, which gives me 134.95. So roughly speaking, and what I needed to do then was compare this to the number 100, because 100 is our average, and so in this situation, because we've got 135%, we would need to increase our increase by 35% to correct for the rainfall. Sorry guys, what you don't realize there was I had a little bit of a technical difficulty, so if that little bit's disjointed, my apologies. And moving on to the next question, it wants us to look at the long-term mean rainfall for December. Well, we know that we have to work out the mean, he said, having written it on here already, to allow us to find the seasonal indices. So we just have to backtrack it, and I'm going to use October. And all I did was decide to do 82.4 divided by 1.156, which gave me the value, as I say, of 76.4 milliliters. These are all formulas that should be in your summary book. Okay, table 4 shows the monthly rainfall for 2019 in millimeters recorded at a weather station and the associated long-term seasonal indices. This is, again, based on the stuff we've done, the deseasonalized rainfall for May 2019 is closest to. So we want the deseasonalized rainfall. Again, it's just a formula. We want May. And so the formula basically tells me, he says, to do 92.6. All right, so we have 92.6 divided by 1.222, and that gives me, oh yes, the deseasonalized value, which I want to put into my calculator, gave me B as my answer. All right, again, all in the textbooks and the summary books, very, very useful. The 6 mean smoothed monthly rainfall. Now again, when I did this first question, I did this wrong. I actually did the seasonal indices. Muppet. But we are going to, now because it says 6, it's an even number, it's a little bit more complicated. They probably weren't going to give you a 5 mean smoothing. Centering on August. Now again, when I taught my kids this, because we want it centered on August, we need to draw, I get them to draw a line on the left-hand side of August and the right-hand side of August. Now the reason I do the left-hand side of August is because that helps us work out where we are centering our data points on. Because I want 6, I want 3 on one side of the line and 3 on the other side of the line. So there we go. Those are the 3 pieces of information either side. They're my 6 data items. And again, I put that into my calculator, added those together, divided by 6, and that gave me a value here of 80.9. He says with his calculator or computer overheating. Now, having done that, what do? I effectively delete those values, delete that line, and now I do the same for the other side of August, choosing 3 on that side and 3 on that side. Add those all together, divide by 6, and I got 81.683. And now that I've got both sides of August, I now need to center it on August because that's not centered at the moment. And the way to do that is we did 80.9 plus 81.683 and divided it by 2, which when I put that into my calculator gave me 81.3, or at least that was the closest answer. All right, the following information. Time series plot below displays the number of airline passengers in thousands. Now again, there may be other ways of doing this, but this is certainly the way that I did it. During 1960, the median number of monthly, the median means the one in the middle. There are 12 data items because we've got the 12 months. And what I'm trying to do then is say, well, if I've got 12 data items, add 1 gives me 13, divide that by 2 gives me 6.5. So effectively, I'm looking for the 6th and the 7th data item. How did I do that? Well, I went, that's my lowest, 2, 3, 4, 5, and it would appear that that one and that one there are my 6th and 7th, which pretty much seem to be in the same place. So when I looked at that, that was 460,000, and again, it wants the one that's closest to 460, and so I decided it was 461. Again, I don't know there was information there for you to be able to accurately add up all those values and then sort of divide them by 12. That was the best way I could come up with it. During the period January to May 1960, the total number of airline passengers was 2,000. 2,160,000. The 5 mean smooth number of passengers, and this is one of the stupidest questions. Yeah, it was really that silly. Remember, to work out a mean or a 5 mean smooth number of passengers for March, basically 2160000, and I just divided it by 5. Oh, isn't that annoying? The 5 mean smooth number of passengers for March is that. Because January, February, March, April, May, those were the 5 months. March was in the center, just added those together, divide by 5, and out came the value of, he says, flipping it over, D, 432. And I have to say, I initially did that wrong. I couldn't get the right answer, and it frustrated the life out of me. Oh, maths, big fat trick. Obviously, moving on to the next core module, recursion and financial modeling. The following are recurrence relationships. In this situation, we had T0 was equal to 10, and our recurrence relationship said to get from one term to the next, add 3, which gave me T1 was equal to 13. And because the question said the number of 13 appears as, I put A as my answer, and hopefully the correct answer. An asset is purchased for $2,480. And again, trying to read this, this is my V0. So V0 is 2480, and it's given me an equation in terms of n, it's given me a rule, but now it wants me to go to a recurrence relationship. Now I know here then that that rule basically means that I'm taking each term and adding on 45 to get to the next term. Okay, so again, trying to decode these things is probably half the battle. So if I write that down as to get to my next term, take my previous term and add 45 and then match it, I think question 22 came out with C as my correct answer. Consider the following 4 recurrence relations representing the value of an asset after n years. How many of these recurrent relationships indicate the value of an asset is depreciating? So to depreciate, it's got to be going down. Now, it's great that all of these start with 20,000. And some of these were a little bit tricky. Now, the first thing is, because we're adding on 2,500 here, the value is getting bigger, so it can't be that one. It could be this one here, because we're taking our last month and taking 2,500 off, so it could be that one. Here, it definitely could be that one, because when we multiply by a value less than 1, that will reduce. This one here was an interesting one, because what you needed to do was work out 20,000 multiplied by 1.125. So again, when I did that on my calculator, 2123 times it by 1.125 gave me 22,500. Now what that basically means is that when I took away the 2,500, I ended up back with the 20,000. This one here is actually a perpetuity, so no, and that gave me C as my correct answer. Manu, I have a friend called Manu, or at least I used to, not the famous guy from My Kitchen Rules, but anyway, Manu invests $3,000 in an account that pays interest compounding monthly. The balance of his investment after n months can be determined using that recurrence relationship. The total interest earned by Manu's investment after the first 5 months. Now, when I did this, I basically just put this formula into my sequences, and I worked out and said, well, okay, how much money did I have in the bank after those 5 months, or Manu have? And basically just reading off the screen, and again, not doing that in this particular question, gave me $3,072.69. Because it wanted the interest, you would then take away the principal of 3,000, which gave you $72.69. Question 25, the graph below represents the value of an annuity investment, AN, in dollars after n time periods. Now again, what do you notice? Graph is flat. It is a perpetuity. Okay, so yes, it's an annuity, but it's also a perpetuity, which means the money we are getting paid must be equal to the interest. A current relationship that could match this graphical representation is, well, again, you just have to do what it's asking you to do. That makes no sense. So in this situation, all of them again start with 200,000. So for the first question, just through trial and error, I did multiply by 1.015. So bringing up my cows, 200,123, multiply by 1.015, gave me $203,000. Well, obviously, if I then take away 2,500, I'm actually going to have more than I started with. This value here must equal the interest. So that A wasn't the answer. And again, as I progressed through this, and it actually turns out that B was the correct answer, you just repetitively changed each of those values and worked out which one of the interest equaled that value there. Ray deposits $5,000 in an investment account earning interest at a rate of 3% per annum compounding quarterly. This was a bit of a trick question. It caught me initially, but anyway. So 3% per annum compounding quarterly, turn that into a percentage, add 1 onto that, or into a multiplier, sorry. And what did you have? We ended up with 1.0075, which obviously then meant that they couldn't be the correct answer. So it was, between D and E. Which one did we choose? Well, as far as I'm concerned, the trick was here that they've got 4 payments every single year. Okay, this here is your value compounding quarterly. That's every quarter, and there are 4 quarters in a year, so the right answer was E, because you needed to take those 4 quarters and times it by the number of years. Tricky. Jen invests $100,000 at an interest rate of 5.5% per annum compounding annually. After how many years will her investment first be more than double its original value? Now again, I just used the idea that we know that we have 20,000 as my final. I've got 10,000 going in, and I'm going to multiply that by 1 plus 5.5 on 100. Right, so that's my multiplier, my rated multiplier. And I need to raise that to the power of n. How do I do this? Bang it in my calculator, go solve, comma, n, and out comes the fabulous value of 13. Nominal interest rates for a loan at 8% per annum. When rounded to 2 decimal places, the effective interest rate for this loan is 0. And again, brilliant. Love the fact that my calculator has interactive financial interest conversion and conv. So N is the number of times there's a payment. I is my rate of interest. So I'm going to do 8 here. So let's do the first one, charged daily. That's 365. Hit enter, hit enter, hit enter, and out comes 8.33. Yep, that is correct. So that's not the one we're looking for. And again, now I can just highlight these values here and change them to weekly. There's 52 weeks in a year, 8.32. Yep, not the one we're looking for. And actually, C worked out to be the correct answer. Using the calculator, and actually calculator to make things easier for you is phenomenal. The value of a van purchased for $45,000 is depreciated by K% per annum. This was actually quite a tricky question. 29 and 30 were quite tricky. The way I did it was, we knew that in the 4th year we have 30,000 kilometers traveled at 15 cents per kilometer, which gave me, he said, I've got to try and remember this, $4,500. Okay, so that's how much it depreciated by. Because it ended up at 26,166.24, I then have to add that on. So I'm almost doing this question in reverse to tell me how much it was worth at the end of the 3rd year. Because again, it's important that 3 years of one depreciation. We have got a change in conditions question. So when we add that on to 26166.24, we get 30,666.54. So we know it started at 45,000. It ended up at that. What do I do now? Well, I just basically went to my calculator. He says, moving this over for the moment. And I said, right, I know that it ends up at 3666.54. I started at 45,000. What was my multiplier to get there? Well, because it's depreciating, it's going to be 1 minus K divided by 100 to the power of n. Okay, sorry, not n, because we know it's actually 3 years. And again, put that into my calculator, do solve, comma K, and I put X, and out came the value of B, which was 12%. So K worked out to be 12. I'm sure there are other ways of doing it. I tried it with a financial solver, but I kept getting minus 12%, which was very, very random. Something not quite right there. And again, 20 years ago, Hector invested a sum of money in an account earning interest at a rate of 3.2%. You had to do this question backwards. He says, hoping that his calculator is going to be able to do that. So if we go to the financial solver, is it still in here? Actually, as it turns out, it is still in here. The correct answer, I'm going to tell you now, is actually B, because that's the reason why. But let's start at the end. We know the balance of the account is 686,904.0 0.09. That's the final value. He's not making any payments. Interest is being compounded at 2.8% for the last part, so 2.8 monthly. No payments being made. He does it for 10 years, so that's where my N of 120 comes from. And so when I go back to my principal value, I get 519,320. So that's how much he had at the end of the 10 years. Now, this is the interesting bit because he added 10,000 to the account. So what I now need to do is I need to copy this value here. So I'm going to go edit, copy, because that becomes my new final value. But I have to knock off $10,000. Because he added that $10,000 between the change of conditions. So actually, after the first 10 years, he only had 509,000. The interest rate worked out to be 3.2. And again, if I change my principal value, it gives me $370,000. And there we go. That's a pretty funky question. I've never really seen them done that way before. Okay, we're now going to move on to the modules, and matrices I think is probably the one that most people did. I know that certainly many schools taught this one. Matrices, pretty funky. Geometry, pretty funky. Networks, not a great fan of, to be perfectly honest with you. It's been a long time since I've taught that module, so yep. And then obviously linear is just linear. So matrices, let's go through these. The matrix is an example of a binary matrix. It's definitely binary because binary is ones and zeros. Identity, nope, because for an identity matrix, it has to have ones on the diagonal. Triangular matrix is zeros above or below, and that's not the case here. Symmetric matrix, that's where you do the transpose and it would look exactly the same. That's also not the case. And a permutation matrix has a 1 in each row, and that's not the case either. So as far as I'm concerned, a binary matrix is the correct answer. Question 2, the elements, rows and columns. Right, so basically they want you to find element Q41, which tells you to take the fourth row and multiply it by the first column. So again, that's exactly what we're going to do. We take the fourth row and multiply it by the first column, which when you multiply that out longhand, you do the first number times the first number, 4 times 2, 5 times 4. And they didn't want the actual answer, they just wanted the calculation, which gave me E. Matrices P and W are defined below. Now again, this one I had to do by trial and error. I'm sure people probably put all of that into their calculators. I really couldn't be doing with that. All right, so what I did was just trial and error. And I said, well, okay, what would happen if I do this once? And I got T-R-S-O-A. And I just said, well, okay, now let's do the same to that one. I got S-A-R-O-T, and then R-T-A-O-S, and then finally A-S-T-O-R. So I had to do it 4 times. So N in that situation would have been 4, which gave me D as my correct answer. In a particular supermarket, the top 3 selling magazines are Angel, Bella, and Crystal. Transition diagram below shows the way choose from week to week. Okay, and then it says, well, okay, now basically show what the transition matrix is. And I started off by saying, well, okay, we already know that all of them start with 0.55, so that's no use to me. Let's have a look and say, well, let's have a look at this value here. But it starts B to A. So B to A is 25%, so we're looking there for a 0.25. That's not true, and that's narrowed it down. Okay, so now let's look at differences here. It would appear that, he says 0.55, 0.25, 0.3, yeah. So here we go, we got a 0 here. So is there no connection between C and A? Well, actually, there is a connection between C and A, so it can't be that value there. And again, if we look at this value here, is there a no connection between A and C? Well, going from A to C, there's no connection. It can't be that one. So C, in fact, is my correct answer. Trial and error. Looking for the differences in those transition matrices is actually probably the best way to do this. Looking at question number 5, I did exactly the same thing as I just did a moment ago. Sorry about this being really small, but the diagram below shows a direct communication link that exists between Sam and Umi. So again, what I did was I said, well, Sam can only talk to Ty. So because these things are symmetrical, Sam can only talk to Ty. That means S will be, so the sender for S will be a 1 and T will be a 0. So S, that one, yes. So that's correct, but that's not correct, yes, because T can't talk to S. So that has to be a 1. Are there any matrices there? Oh, that's annoying. They all have 1s there. Okay, so let's look for another point of difference here. All right, so is that even possible? No, because if there's a 1 here there had to be a 0 here. So B can't be, because while Sam can talk to Ty, Ty can't talk to Sam, so we can't have it the other way around. What else? Well, we got some 2s here. Are there 2 ways of Sam talking to S talking to V? Well, no, because that doesn't make any sense. Sam can talk to Vera. It's not a 2-way, it's not a 2-step, so that doesn't make any sense to me, so that one's gone. Where else? I know that Umi and Ty can only talk 1-to-1, so Umi to Ty, yes, that one works. Umi to Ty, yes, that one works. Umi to Ty, yeah, that one works, so that's no use. And basically, I just worked all the way through. I'm not going to make this any longer than it needs to be, and I found out that D was in fact our correct answer. Trial and error. The elements in this row are, again, these questions come up all the time, and I have to say I sort of quite like them. What I tend to do here is do a 3x3 matrix, 1, 2, and 3. Those are my rows. 1, 2, 3, there are my columns. And it says the rows are multiplied by 3, and the columns are multiplied by 2. Okay, well, that's fine. Let's do that then. So we've got a row number of 1. So this number here is going to be, 3, because 3 times 1. 2 times 1 is 2. So that's going to give me 5 there. There we've got a 5 in them. What about the next one? 3 times 1 is 3, 2 2s are 4, add those together give me 7. So that can't be that one and that one. The next one is 3 times 1 is 3, 2 times 3 is 6. That's going to give me 9, so it can't be C. And notice what we're doing again. We're just narrowing this down step by step by step. It would appear that we now only need, because there's a 7 here and an 8 here, we only need to do that number there, and we're going to find the difference. So this number here is 3 times 2, 6 plus 2, which is 8, and so in which case B is my correct answer. A small shopping centre has 2 coffee shops, Fatima's and Giorgio's. Now this question was awesome because it, I think, had 2 tricks, or required you to think about this. So the first things first is you did a transition matrix of 0.85, 0.35, 0.15 and 0.65, and we are going to multiply that by, well, it says here that 40% on Monday went to Fatima's and 60% must have gone to Giorgio's. Now that's Monday. It wanted on Friday. So Monday, Tuesday, Wednesday, Thursday, Friday, it means we raise that to the power of 4. And when I put that into my calculator, out came the numbers something like 68.125 and 31.875. You just then had to choose the right number, and it wanted Giorgio, which is actually this value here. And so the correct answer, as far as I'm concerned, came out to B. The table below shows information about 3 matrices, A, B, and C. This, I thought, was one of the most funky questions I've done in further maths for a long, long time. Transpose is where you swap the rows and the columns. So if we look at this and write it longhand, that's 3 times 4, which is C. I'm going to write the transpose, times A, which is 2 times 4, transposed times B, which is 2 times 3, and then we were transposing that all together. So let's start the transposing. That then becomes 4 times 3. That becomes 4 times 2. That stays as 2 times 3, but I'm going to transpose it once I've done it. Are the middle numbers the same? Yes. So the n numbers are the result of what comes out. Transpose that gives me 2 by 4. That's awkward because my handwriting is, that's a 3, that's a 3, 4 by 3. Now, how did I know I'd made a mistake there? Because those middle numbers wouldn't have been the same. And so ultimately, because they are the same, my outer numbers give me a 4 by 4 matrix as a result, and E would have been my correct answer. Question number 9. I personally did this by trial and error. Okay, so I worked out that because only one person can win against the other, if this is a 1, that has to be a 0, and vice versa. If that was a 0, that had to be 1. So because I've got 4 numbers, or 4 of those spaces to choose, then I had 4 different ways of doing it. I had 0, 1, and for example, 0, 1. I had 0, 1, 1, 0, 1, 0, 1, 0, and 1, 0, 0, 1. So those are the 4 ways I could have filled each of those in. And actually that's what I did. I programmed my calculator to basically put that into A, and then I said, well then for each time please show me A plus A squared. I added up the individual sort of totals for each of those matrices, and what I ended up with was one of them came out to be 29744, which told me, and that was the highest value. Brie ended up to be the highest value, and so Brie was my right answer, so I circled B. Consider the matrix recurrence relations below. Again, I really like this question. It was a little bit funky. What do we need to know? Well, first things first, we knew that the transition matrix was J 0.3, L 0.2, M 0.3, 0.4, 0.2, and N. And there are a number of ways of doing this questions, to be honest with you. S was 30, 20, and 40, and that would have given me 42, 28, and 20. Okay, so basically, long story short, we know that columns have to add to 1 for transition matrices. So that gave me that J was equal to 0.4. And again, M could have been worked out, and it worked out to be 0.5. So M, he says writing in highlighter. So M is equal to 0.5. Those are two of my values. How could I then find L and N? Well, I just used that top value there as 0.4, and I know that for matrices, if I multiply that row by this column, I'm going to get that value there. And so that's effectively what I did. I did 0.4 times 30 plus 0.3 times 20 plus L times 40 gave me 42. Put it into my calculator and did a little bit of funky movement around, and out came the value of N as equal to 0.1 and L was equal to 0.6. And then working through each of those, the only one that was true was that L was equal to M plus N, which it does. And there we go. And that was matrices. Okay, networks and decision matrices. As I say, I haven't taught this for a long time. Fairly sure my answers are correct. But again, if there are any errata and you think there are errata, please let me know down below. And if you think the explanations could have been better, again, write them below and I'll copy them into the main text. Okay, so networks and decision. The connected planar graph has 7 vertices and 9 edges. Funny enough, I remember this formula as very fat elephants equals 2. Vertices plus faces minus edges. We know that we have 7 vertices. We're trying to find F. We've got 9 edges equals 2, which basically gives me that F is equal to 4, and hence D is my correct answer. Consider the graph below. Which of the following is not a Hamiltonian cycle? Again, have to look that one up. Hamiltonian cycle will visit each vertex only once. All right, so you can only visit each vertex only once. So if we look at the first one, A, B, C, D, F, E, G, A, that is a Hamiltonian cycle. Sorry, a Hamiltonian cycle will start and end at the same one. So, yep, that actually works. So A isn't the correct answer. Let's do B, A, G, E, F, D, C, B. Yep, seems to work. And basically, when you keep going through these, what you find out is that D is the incorrect one. And the reason being is because they try to get you to go from E to D, and there's no direct path between the two. And so that's actually just not possible. Which of the following is not a spanning tree for the network? He says, zooming so that you can get all of the question in. Well, again, it's got to have the same connections between the trees to be able to be a spanning. And what we find out is actually B isn't correct. And the reason being is there's no connection between 3 and 5. Same as we did actually a little bit in that previous question, all right? So actually B isn't correct. All of the rest of them work. And again, that just went through by trial and error. Question number 4, again, I'm not massively a fan of this question. Again, the theory I couldn't necessarily pin down on this one, but I'll go with the consensus. The directed graph below represents a series of one-way streets. The number of vertices that can be reached from S, well, there's S. I know I can get to T, and I know I can get to V, but apparently I can also get to X by passing through V. Yeah, you can't get to any other vertices. So the consensus of that question is in fact C, which is 3. Interesting. The network below shows the distance in meters between campsites at a camping ground that has electricity. Okay, so a number of ways of doing this. I started off by saying, well, okay, I'm going to start at H and I'm going to look for the smallest number. That got me to G. Look at G. What's the smallest? I've got 10 and a 6 coming on. 8, 9, 10, X, 9. Well, I've got to choose the 6 in this situation. I've got a 7 coming off, 10, 11, X, 9, so a 7. What do we reckon here? So we've got a 10, 11, a 9, and an X. Now, as far as I'm concerned, if we assume that X there is the smallest number, okay, then when you continue going around it and you add up all of the values you get and put it equal to 53, because they're telling you it's 53, then what you actually end up with is the value that X probably is at least 9. To me, it sort of made sense because when I did it a different way, it had to be 9 for me to be able to choose it. Network activity low shows the sequence of activities required to complete a project. The minimum completion time for the project in days is, I hate these things with a passion. They're funky, but God, they're annoying because they just take like an hour to set up. So just while I draw random boxes, and I have no idea there why my pen color changed mid-flight. I think it's because my computer's trying to record a 2-hour. Oh, nope, not there. You gonna rub it out? Yep. See, I'm talking to it like it's an actual person. If that's not worrying, nothing is. Okay, so 0 here, that's got to be 4, and that's got to be 7, because there's only one way to get there. To get to this one here, I'm going to add on 2, that's got to be 6. To get to this one here, I can go 2 ways. I can go 4 to 6 is 10, or 7 to 4 is 11. So it has to be 11 because I have to choose the largest value. Again, to get from 6 to there, I've got to add on 9. Again, I have 2 choices. It could be 15 by the 6 plus the 9, or it can be 11 plus 3, which is 14. I have to choose the biggest number, which gives me 15. To get to I, so to pass through I, there's only one way, so that's got to be 14. To get to this point here, I can either go 7 plus the 8, which gives me 15, or 14 plus 3, which gives me 17. Have I got everything? Yep, and obviously there's 3 ways to get to this box here. 17 plus 5, which is 22, 14 plus 6, which is 20, or 15 plus 5, which is also 20. And as far as I'm concerned, that means the, what does it say? The minimum completion time for the project is 22, which is E. This one here, again, he says, hoping the diagram is going to show up any minute. No, there is no diagram because I have to draw it. When you actually draw this, I actually did it as, it's obviously a bipartite graph. So I'm already going to put that G and I. I'm going to actually do it so that my ice creams are S, C, V, and L. Because what we end up with is we get a diagram that looks something like this. Now, when I looked it up online, I'm fairly sure it said a graph that is bipartite is also planar. The graph is connected. Well, yes, all those parts are connected, and the graph would be a tree. Again, yes, that could be drawn in a different way as a tree. Again, if I'm honest, my knowledge of this is a bit sketchy, but again, the consensus for this seems to be E. If you can explain it better to me, please do. Leave a comment below, and life is good. Right, adjacency matrix. Again, there seems to be a lot of trial and error here. So basically, number of pathways collecting the J, K, L, and M. And the first one I looked at here was that one tells me that there's only, it's a loop. There's only one way to get from J to J. Now, there is one way to get from J to J, so that's okay. We can't do this one here because there's no way to get from J to J without going through any of the other landmarks. C also not possible. As it turns out, E is possible. And J is also, and that D is also possible. All right, so those have narrowed down 2. Then it says there's 3 ways between J and K. So there's 1 way here, 2 ways there, and unfortunately I couldn't find a 3rd way. So that actually discounted that one there. 3 ways, 1, 2, 3. Yep, so B is a possibility. E, 1, 2, 3. Yep, that's a possibility. No ways between L and J. So there's no ways between L and J. I'm getting confused as to which ones I've got left. L and J. Yep, so both of those. And eventually, again, not trying to string this out, there is a way that B gets discounted, which leaves E as one of the answers. Again, just work your way through that as you can. The flow of liquid in a series of pipelines. This question was not funny, all right? It really wasn't funny. And I think it was a bit tricky, if I'm honest with you. Sorry about that. Let's just take that off. 5 cuts A to E, and you had to find obviously the maximum flow is given by the minimum cut. So when we look at the cut from A to E, you've got to realize that a cut is only counted if the water can flow through it. Now what I'm saying is here, if we look at the 3 cuts for cut A, we can find a path through that cut to get from the source to the sink. So that's a valid cut. Yeah. Likewise here, we can go from there up, down, along, and in that way as well. Right. So that 15 is a valid cut. And likewise, if we go down here, we can find, in fact, a number of routes that can get there. So we count all of those 3 numbers. Yep. So when you do that, and obviously the theory behind this is you do, what was it, 8 plus 15 plus 15, then you get there 38 as that particular cut. Right, so there's 38. When you continue using the same idea, you get 33 for here, 33 for here, 33 for here, and then, well, when I did cut E, I thought, oh, okay, that's awesome. It's going to be 38. Actually, no, it isn't, and I'll show you why. There is absolutely no way to get down there. There is no way to get through that pipeline. It just doesn't exist. It's not possible. You can't get to it by here because you go backwards. You can't get to it by here because you have to go backwards down the arrow. And as such, that 5 wasn't included. That annoys me, if I'm being brutally honest, which means that D would be my correct answer because 4 of them would have 33. And again, the maximum flow is the smallest cut size. Oh, that just frustrates me. Okay, directed networks. Again, what I did was I started off by doing my boxes. And again, I'm going to shortcut a lot of this because it could take 20 minutes just to explain this one question, if I'm brutally honest. And maybe again, as I said last year, I'll do a video specifically on this. But if I now look at the fact of trying to find out what my earliest completion date is, this is 0, that becomes 4. To get to here, I'm going to do 9. To get up here, I'm going to do 7 because there's only one way to get there. What am I doing? Try that one again. Sorry guys, let's just do that one again. Be all right if I could read my handwriting. So that's actually 2. That's 5. That becomes 7 there. There are 2 ways to get to there, but you know, 2 plus 4 is 6. 2 plus 5 plus 3 is 10. So that actually becomes 10. That would become 16 because there's only one way to get there. Again, this can be 5 plus 6, which is 11, or 16 plus 4, which is 20. And then 20 plus 5 gives me 25. So under the standard conditions, or under the standard rules, that would give me 25 weeks to complete. Obviously, with the project manager wanting to basically shortcut or sort of cut things down, first things first is he says, well, actually, this value here can change to 3. And then you can only do, you know, they're giving the people from H to F. So basically H can't start until F is now finished. So you have to do a dummy here. All right, so D, 0 is a dummy to actually allow it, or to say that, you know, H can't start until F is finished. When you do all of that and you go through and change all these numbers, this number here becomes 24. So basically, as far as I'm concerned, A is the correct answer. If you do work through B, C, D, and E, they aren't actually true. But, you know, as I say, it's 20 minutes long just to do this question. Next module, geometry and measurement. I love this. Again, question number 1. My brain is fritzing a little bit on this one. I love the time stuff, but as far as I'm concerned, the sun, if we have this as east and west, and we have 0. I know that I'm in Melbourne. My parents are in London. They are behind me. We get the sun first. So the further east you are, the more, that's where the sun rises. That's where the day starts. Now, obviously, if you get to a situation where you've gone over 180 degrees, you're actually back on the west, and theoretically, your day starts much, much later. That's the theory. So Looking for the value that is the furthest east gives me 147 degrees east. It's not bigger than 180, and so as far as I'm concerned, E should be the correct answer. But I don't know, my brain keeps saying to me, I'm missing something, it seems too easy. Flag consists of different coloured sections. The great thing about here is they gave you this question and they said that the blue section is an isosceles triangle that's basically half the length of the flag. So what they were doing in code was telling you that that's actually 1.5. Awesome. So knowing that, I've got a trapezium, I've got exactly the same trapezium. So using the area of a trapezium, I've got that as 1.5 plus 3, which you add the parallels, multiply by how far apart it is, and that's only 1 meter there. Divide by 2, that's for one trapezium, and I'm going to double it. So those twos cancel out, and that gives me that the area of the combined trapeziums is actually 4.5 square meters. So now to find the area of the blue section, I know the whole area of this thing, because it's a rectangle, is going to be 6 square meters. Take away 4.5 gives me B as my correct answer. 2 trees stand on horizontal ground. Love this Pythagorean theorem. Pythagoras, there we go. So what do we know? We got a right angle triangle, that's 25. We're trying to find that. We know the difference in height here is because that's 45, that's 13, so that must be 15. And again, ladies and gentlemen, lots of ways of doing this, but I just bang it into my calculator by doing the square root of 25 squared minus 15 squared, which gave me 20. So the distance between them was 20 meters. Again, lots of different ways of doing this question. One of the ways is that we know that these three angles here are the same. 360 degrees in a circle, so that must be 120 degrees, 120 degrees, and 120 degrees. And I know that when I have parallel lines, he says, hopefully highlighting this now, when I have parallel lines, I know that the angles in the corners of those parallel lines add up to 180. I've already got 120, so that one there must be 60. That's not the way I originally did it, to be perfectly honest with you. I did the idea of external angles. And I know that each of these angles here are the same. There are 6 of them. 360 degrees divided by 6 gave me an exterior angle of 60 degrees. And again, that was 120 degrees. They're both equal in size. Divide by 2 gave me 60. 2 different ways of doing it. Choose the one that makes the most sense to you. Pie chart displays the results of a survey. They've told me the radius of this is 16 millimeters. Why are they telling me the radius? Because they're going to try and find me a percentage of an area. Because we want the agree, we know that we've got 80% of 100%. That's my fraction of the circle, and I want that fraction of the area. Because the area of a circle is pi r squared, I know that r is 16. So 16 squared. Put that into my calculator, and lo and behold, out comes the fabulous answer of 643. The city of Lhasa, Chengdu and Shanghai are all in the same time zone. Now again, what I did here was I always do this 0, and I've got Shanghai at 121. He says writing 21. He's got Chengdu at 104. And I've got Lhasa at 91. Now, again, it's no real coincidence. There's roughly 15 degrees between each of those. And so I now know that there is 1 hour time difference between each of those. Now, again, because I know that I'm in Melbourne and my mum is, my mum and dad are in London, I know that the time is going backwards. So whatever time it is here, it's going to be 1 hour backwards there, and 1 hour backwards there. So as far as I'm concerned, this means that C has to be the right answer. The sun rises here approximately 2 hours after it rises there, all right? So yeah, if it rises at 9 a.m. here, it'll rise at effectively 11 a.m. Shanghai time there, all right? So again, draw those diagrams. Life is good. Cape Town has a latitude 34 degrees south and longitude 18 degrees east. Stockholm, again, I tend to draw a circle here. I know this is my equator, and I know that Stockholm has latitude 59 degrees north, so I know that that's 59. and I know that this here is 34. Now, why is that important to me? Because I'm now looking for some sort of arc length of this whole circle. We know the circumference of a circle is 2 times pi times r, but I've only got a fraction of that circle. And what fraction have I got? Well, I do 59 degrees plus 34 degrees divided by 360 degrees. So 360 degrees in a whole circle. And again, putting that into my calculator and bearing in mind R, they tell you, is 6,400. Yep, out came 10388. A cake shop is in the shape, sorry, a cake even, is in the shape of a rectangular prism, and it's cut in half. So when you cut it in half, you're going to get this section here, and it wanted the surface area. Now, the surface area was awesome. Much of it was easy, barring this section here, which you had to think about. That's the section you can't see, that section through the center. If the computer will let me delete those lines for a second, it will. So I know that this area here is 36. I know that this area here is 48. I know the area here is 24, and the bottom section is also going to be 24. Why? Well, we've got the top, which was 6 by 8, which was 48, but because we've only got half of it, it's 24. So far I've got 24, 24, 36, and 48, and I just need to work out this sort of face that I can't see. Well, we know the height is 6, so all we need to do is find that diagonal length there, and again, we go back to our old friend Pythagoras, because we've got 6, and we've got 8. And again, you didn't really need to use your calculator because that's actually just twice as big as a 3, 4, 5 triangle. And so that value there came out to be 10. And with that 10 and the height of 6 gave a 60, and add all of those together and it gave me C of 192. Shot put is an athletic field event in which competitors throw a heavy spherical ball. Now, okay, so we ended up with 2 spherical objects, female and male, and we know that the multiplier was 1.25. Now that's the multiplier of length. When you remember, because we're looking at the surface area, so when you do a multiplier of an area, you take the multiplier of the length and you square it. So now I'm going to write that as actually 5 on 4 squared, because that's going to give me 5 squared is 25, 4 squared is 16. Now, what that now means is that if this has an area of 1 unit, this is going to be 25 on 16. And because it wants us to write it in a slightly nicer way, I'm going to multiply both sides by 16, which gives me 16 to 25. And so I think E is the correct answer. Question number 10, I think, was horrible. If I'm honest with you, horrible question. You had to find the length of that line there. And they gave you a lot of information. Now, and I think, again, they did this deliberately to try and trick you. I ended up with 2 triangles, if I'm honest with you. One of them had my bearings on because it didn't confuse me. And one of them had my side lengths on. All right, and I'll explain why that's important in a moment. So we knew, if I remember rightly, so we know that this bearing here was 105 degrees. This bearing here was 142 degrees. How is this important to us? Well, again, using the idea of co-interior angles, when I have 2 parallel lines, the angles in between add up to 180, which told me that I could find this angle here to be 38 degrees. Why was that going to be important to me? Well, again, if I knew this was 105, I could find all of this angle here as being 75. And if all of this is 75 and this little bit here is 38, it meant that that angle in there gave me 37 degrees. So I now know that that's 37 degrees. How is this important to me? Basically, this is a sine rule question and a cosine rule question all smashed in one. So what I can then do is I can say, well, hold on a moment. They've also given me that the height of that is 80. I've got that length there, which means I can find that length there using, yes, once again, Pythagoras' theorem. Again, not showing you how to do it, but when you do 170 squared minus 80 squared, that gave me 150. Repeating the same thing with that being 80, that 234, I found that to be not as nice, 219.899, and I left it as a decimal for my whole question. And then I wanted to basically find, what did I want to find? Did I have another angle somewhere? No. So I now needed to find this angle here because I've got a side and an opposite angle. I've got a side and I can find that angle there. So using the sine rule, I had 150 on the sine of 37 is equal to 219.899 divided by the sine of x. Now, when I did that calculation, again, I'm not going to say what the calculation was. It came out to be 61.92 degrees. Why is that important to me? Well, I've got two sides. If I can find the included angle, then I can use the cosine rule. There was a lot that could have gone horribly wrong with this question. So we know angles in a triangle add up to 180. That gave me this angle here as 81.08 degrees. And then I use the cosine rule basically because I've got two side lengths and an included angle, which ultimately when I use the cosine rule gave me 246.22 and C as my answer, honestly. Last module, graphs and relations for those of you who did this one. I thought this one was actually pretty funky. It wasn't too difficult. Apologies if you found it difficult. That probably came over as incredibly condescending. How many hours were there? At least 600 people. What I did was I drew a line along at 600 and it wanted to basically to find how many people were above that line or how long people were above that line. So 2, 3, 4, 5, 6. So to go from 2 hours to 6 hours is 4 hours. C was my correct answer. School concert, the entry fee for adults, blah, blah, blah. So this was creating a set of simultaneous equations. We knew that we had, what did it say? 2 adults and 4 children was one sum. 2 adults, 5 children was another sum. And so, bearing in mind they wanted adults to be x, we had 3x plus 4y is equal to 67. And we had 2x plus 5y was equal to 57.5. Comparing that gave D as the correct answer. Step line graph, is that called a step graph? Step graph, that's the one. Step graph was lovely. Basically, which one of these is not true? Right, so let's just have a look at a couple of them and then I'll tell you which one it was. A delivery fee for a 4 kilogram package, which is there, is 20 bucks. That's true, so that's not my right answer. Delivery fee for a 12 kilo package is 26. 12 is 26, is that right? Yep, that's right, so it's not that one. Delivery fee for a 13 kilo parcel is the same as for a 20 kilo parcel. That is true. So narrowing it down, we had D and E. And basically, from what I remember, is it E? I think it's E. Yep, it's E. So when you actually do the delivery fee for a 12 kilo parcel is that one there. The delivery for a 2 kilo parcel is that one there. So you had 26 minus 12, which is 14, not 18. So there we go. That's why that was the incorrect answer. Straight line is graph below. There's lots of ways of doing this. There's a formula, and again, I'll be blowed if I can ever remember what that formula is. One of these days I'm going to learn it or have it tattooed somewhere. Tattooed. The way I do this is I always go, well, 10x plus 8y is equal to 40. So I start the first one and I ignore that, and I say, well, when x equals 0, 8y is equal to 40, so y would be equal to 5. So is that 0.05? Nope, so that's not one of them. 4x plus 5y is equal to 40. Again, make x 0. 5y gives me 8, so when x equals 0, y equals 8. Yes, that's certainly possible, but we then have to say when y equals 0, x is equal to 10, y equals 0, x is equal to 10, and as it turns out, B is the correct answer. I know there is a formula that can do this a lot quicker for you. The graphs show the same relation between that and that. Okay, so what we know when we do this is that if I am doing an x squared transform, this point here, which starts at 430, ends up over here as 4 squared, which is 16, 30. Well, now that we've got a nice straight line, we can find the gradient by doing rise over run, which is 30 minus 0 divided by 16 minus 0, which is 30 on 16, which is 15 on 8. So B is the correct answer. And again, I'm sure a number of people got tricked with that one. Question number 6 talks about revenue and sort of costs and profits. All right, so what you've got to realize is that your profit is your revenue minus your costs. So the first thing I needed to do was work out my revenue. So how much did I get in? Well, he made 200, he charged 27 each, and that gave him 5,400. So that's how much money he got in on the day he was out there selling the stuff. The costs, where he had a fixed cost of $420, so that was a one-off cost. But then he had to pay $15 for each of the boards. And so when you worked out 420 times that, you got 3,420. So that was my revenue. That was my cost. The profit was the difference between them. So taking them both away gave me a 1,980. Question number 7 tricked me. Again, so annoyed when I did this the first time. The trick here is it says on average in a day, but they give you information with regards to months. So basically, to do this question, he says, hitting that button too much, an energy company makes a monthly service fee of that, so $38.70. Now, I actually converted all of this into cents. The reason being is that that was in cents. So making that 3870 plus 2.5 times, I'm going to say E for the energy used, and we know that for the 30 days of June, it was 16990. So when you take away this from both sides and then divide by 2.5, you ended up with a value of E, which I don't have on me. I think it was 5248. That's for the month. It then wanted the average for the day. You then needed to divide that value by 30, which in fact gave you C as the correct answer. So annoying. These questions here I hate with a passion, all right? Absolutely hate with a passion, but the way I tend to do it is I say, right, well, we know that X is the number of meat and Y is the dry food, and it says that no more of 2 units of meat for every 5 dry food. So I go 2, 4, 6, 5, 10, and 15. So I now know that this here is if they have 6 meat, they can have 15 dry food. And when I connect that together, I get a straight line. Now, if I've got a straight line, I can find rise over run. So this point here is 6, 15. We know this point here is 0, 0. And when we do this, we can say the rise is 15 on 6, which is 5 on 2. Right? So we now know the equation of this line is y is equal to 5 on 2x. Now, to work out which section of the graph we actually need to use, I just test a point. And I've tested this point here, and that says 6 meat and 5 dog food. Now, looking at this here, if I have 2 units of meat, then basically I can't have 5 units of dry food. So the area I'm looking for to be shaded is here. Again, I tend to just choose a point, and I say, well, okay, I've got the point 2, 10. And I say, well, if my y value is 10 and my x value is 2, then if we look at the formula y is equal to 5 on 2x, we know y is equal to 10, x is equal to 2. They cancel out, which means that 10 is greater than 5, and so this section here is greater than or equal to. So this section is going to be y is greater than or equal to 5 on 2x, which gives A as the correct answer. Question number 9, we're almost at the end of this video. I promise you the graph shows below the volume of water. It takes 80 minutes to empty. That was good. They told me that we had 1180. And it says the volume of the water tank decreases by 300 litres in 20 minutes. So what I now know is that value there is 20, and I'm going to take 300 away from that to give me 800. We then also know that the last part of the volume actually goes down 32 litres per minute. Well, we know we started at 800 litres. If I divide that by 32, I find out the number of minutes it's going to take to empty, and that actually is 25. So it means that that distance there is 25. So if I do 80 minus 25, I get 55 here. And we're still not finished because it wants to know the volume, it wants the period in minutes for when the volume didn't change. So it wants the difference between 55 and 20, which gives me C as my correct answer. And finally, last question of this particular video. And there are other videos coming. I have done the answers for paper 2 and for methods paper 1. So those videos coming soon. The feasible region for a linear programming problem is shown below. Now, long story short, if C is maximized, if it's going to have to be maximized at C, it means that our gradient, our line for our objective function can only hit C. That's the only point it can hit. And obviously there are lots of lines that could be, he says, drawing them. But what we know, he says, trying to rub these out and wait for the computer to catch up, is that this gradient of this line here, this objective function, which is Z, is equal to bx plus 4.5y, has to be less than the gradient of this line here. Because if it hits that line there, then there's going to be multiple points along there, and so C isn't going to be maximized. Now, the reason it's less than is because, if you remember, the gradient is negative. So this objective function here has to be more negative than the gradient of this line. So again, we can find the gradient of that line because we can do rise over run. We've got two coordinate points, 0, 14, and 7, 0. So if we do 14 minus 0 divided by 0 minus 7 gives me -2. So we know the gradient of this line here is -2. We can rearrange our objective function, he says, writing the wrong thing again. Come on, computer, catch up. Bx plus 4.5y. We can rearrange this to give z minus bx equals 4.5y. And z divided by 4.5 minus b on 4.5x is equal to y. So which part of this is my gradient? Come on, computer. It is that section there, including the minus. So we now know that that gradient, this minus b on 4.5, must be less than -2. Multiply both sides by the 4.5, gives me that minus b has to be less than -9. And because we can't have a negative there, remember when we multiply or divide by a negative number, what do we get? We switch the inequality. So b becomes greater than 9, which gives E as the correct answer. And I am done. Thank you very much. If you've made it towards the end, probably only watch bits and pieces. If you can, please click like, subscribe to my YouTube channel. Never going to be rich, never going to be famous, but it's just nice to know that actually you've watched the video and found it helpful. There are more videos coming soon. Lots of videos on my YouTube channel. Again, if you're watching this in 2021, trying to prepare for your further maths, hopefully all will be good. Let me know if there's anything I can do to my help. This is Darren, otherwise known as Maths Guru, signing off. I'll see you in the next video. Bye-bye.